welcome back to Build Propulsion Lab at Swiss Cloud Native Day. And my next guest is Sebastian Graf. Welcome.
Welcome. Hello.
And Sebastian mentioned that your talk is about software bill of materials.
Exactly.
But for an unusual applications, let's put it that way. Or not unusual, but not the ones that people usually speak about at the conferences.
Well, I guess, yeah. I guess software bills of materials is quite established when it comes to the cloud native world, and we all are going to generate our S-bombs out of any kind of containers. But when you talk about legacy application, I guess many people are not very eager to put the light on the one hand, and I guess, in my opinion, it's even getting worse when we are talking about LLMs and stuff like that.
Right, so it's like the past and the future.
Exactly.
So generally, software bill of materials has a lot to do with the build. Look at that, and the tracing how our application was created. Right, basically we need to check what were the dependencies and what were the environment that this application was created, and then basically trace all that, pack all that, and kind of make sure that it's available for both manual inspections and automated tools to review and find stuff like security vulnerabilities and all this kind of stuff.
Exactly.
And when it's pretty obvious, or not obvious, but at least well known on how to do it with modern software stacks, with modern tool chains, it's more of a question of how do you do it with legacy applications, for example. So when we're talking about stuff that runs on our mainframes, so how does it? Was it built, and what does it take to collect the bill of materials for those applications?
Well, I guess for mainframes, it's I do not know whether it's entirely possible because they are rather black boxes. What we are now doing over here with the talk over here, it starts with the monolith J2EE containers, Java applications which were, let's call it 10, 15, 20 years old. And over there, we have to face the fact that the software bills of material do not only have to be generated based on the application itself, but also on the application server running the application plus the OS stack. In a container, it's very easy to do so. But on the legacy world, it's quite complicated to do so because we really have to get knowledge about the entire stack.
But let me argue here that with Java, it's actually a solved problem, right? You take Gradle, here's an elephant, or Maven, or any other JVM build, and you just run it with Gradle build scan, and you have the entire picture of how it was created, and you have all the information through the entire stack.
You're right, actually, but the problem is with these old legacy stacks is that it does not end with the application itself. There is also the layer underneath the application, namely the application server. I do not want to name one product, but multiple ones, WebSphere, NetWeaver, you all know them.
Of course.
And we all have them in our basement.
Yes.
And the problem is that those are on the execution path of any kind of programs as well. And we need to generate the software bills of material and to check it continuously as well. Plus the operating systems. With containers, it's a solved problem. But over here, we have to get through the entire stack.
Yes, but also won't it be enough just to note which version of a particular application server running on which operating, on which JVM vendor and version on which operation system it runs as a part of the bill of materials? I can say it was like whatever your WebSphere version X running on Java 21 from Oracle on AMD, like whatever Intel machine. Won't that be enough?
Well, actually, most probably not. No, it won't be enough because you have transitive dependencies. You have either the dependencies directly in the application server, which are not part of the application, and they are optional. So each application server might be set up in a different way, and they are updated in a different way. You got the service packs run through your application servers and not, hopefully not affecting your application, plus the operating system. You got the same problem as well. Let's face it, let's call it something like OpenSSL, stuff like that, which is used by the execution stack, by the requests transferring through the application. And you have to face it that those dependencies are having a different life cycle than the application itself. So this, on the other hand, is generating major problems when you're talking about software bills of material, because you have to regularly update them on the legacy stack, on the entire stack.
Yeah, that's very true. How are there any tools that are capable of tracing all that?
Yes, of course. That's the fun fact, indeed. Many people we're using in the cloud native worlds are also applicable to use it in the legacy world as well. So we are going to use Sift, Graf, open source tools for generating those software bills of material. Of course, you have to adapt the usage a little bit, but you can use them. But you have to use them actually. And my point of view is that it's not used in a regular manner by many companies.
Yep.
I guess.
So now let's go from the past to the future.
To the AI future.
To the AI future. And let's talk about bill of materials in the AI world. And I think this is fascinating because it's something completely different, absolutely uncharted territory, but also quite terrifying.
It is. Because from what I see at the moment is that we are very often relying entirely on this new AI world. We are building up trust against those tools, but we have to face the fact that for most models, it's entirely intransparent how they got trained. They are black boxes. It's even worse. They are black boxes in the operating mode. So you need GPUs to run them. They are SaaS services on the hyperscalers. You're just getting an endpoint where you are going to send your tokens to, and you're getting your answer, and you have to trust the answer. And I guess this is going to generate some kind of concerns in the future when people ask themselves, okay, listen, what are the training data? What is the base of this LLM? How are the weights in this neutral network is going to be generated? And you are entirely right, it's entirely uncharted. And I guess it's a very, very extreme exciting topic. And well, hopefully I get the possibility to take a look at it in the future.
Yeah, no, it's interesting, and what you are saying is that for the neural networks, the bill of materials is the data set that it was trained on.
This is now my assumption, to be honest, because you somewhere have to start. You have to train your neural network, or you have to retrain it. And I guess it's extremely important for some use cases that you get knowledge about the authenticity. Thank you very much. About the data, which acts as a base for the retraining of the models.
And so for dependencies, we know how to express them. We usually do it with checksums that kind of identify them in a very direct way. How can we even try and express a data set which can be anything of anything?
You're right. Actually, it's just an idea of me. I'm currently doing some project ideas about that one. I guess one possibility would be to have a kind of signing approach of the data sets you're going to use for training, and you're going to make a kind of consecutive signing approach for the weights, because actually it's the weights you're going to have to prove afterwards. That would be one possibility, but I really have to be honest, at the moment, I guess it's just a challenge, and I'm looking forward if someone has a way how to do it, or if this needs to get knowledge. I'm really looking forward to see some solutions out there. Yeah.
This is exciting, and I think this is one of the most open-ended interviews that we had at Build Propulsion Lab, ending with a huge question mark how we're going to do it, but it's definitely a very, very interesting topic to explore. Maybe we'll start asking people those questions in those interviews, and maybe one day, Sebastian, we will discover the answer right here. The future will tell. It's definitely a very, very exciting time to live in.
It is.
And there are more questions than answers.
It is.
With that optimistic note, Sebastian, thank you very much. It
Thank
was
you
a
very much.
pleasure. And you'll stay tuned for more interviews of Build Propulsion Lab at Swiss Cloud Native Day, coming right up. Thank you, and
Thanks.
bye-bye.